Hello, grade 10 students. Welcome to the chemistry offline classes. The today main topic is salt. We are still on the unit 2, that is the classification of inorganic compounds. Salts are crystalline solids that have ionic structure and boiling melting points, high boiling and melting points. Salts may have a variety of colors. For example, nickel sulfate may be green, lead iodide is yellow. Sodium chloride is white. A salt results when an acid or an acid oxide reacts with a base or a basic oxide. Base plus acid will yield a salt and water. Solubility is the most important characteristic property of salts. Many salts are solubles. There are also those who are slightly soluble in water, and of course some salts that are insoluble in water. Aqueous solution of salts, they conduct electricity. The naming of salts. To name a salt, we need to first of all we need to recognize whether we have a metal or we have the ammonium compound. Okay, so we have the ones above, they are metal salts. So we have sodium chloride. The metal is sodium and the radical is chloride. So we have sodium chloride. The second one is calcium carbonate. The radical is carbonate, the metal is calcium. For the ammonium salts, we have we need to write ammonium and the negative ion. Okay, so we have ammonium bromide, ammonium sulfate. So we only have these two examples. Salts of ammonia are called ammonium salts. Salts, they may be classified according to the reaction with water. There is neutral salts, acidic salts, and basic salts. Neutral salts are formed by the reaction of strong acids with strong bases. Okay, so we have strong acid reacting with strong base. At the end, we have neutral salt. Example, we have sodium hydroxide reacting with hydrochloric acid. Sodium hydroxide is a strong base, hydrochloric acid is a strong acid. When the two react together, we end up having sodium chloride, that is a neutral salt, and we also have water. Aqueous solution of neutral salts do not exhibit acid or basic properties. Remember that neutral is not positive, is not negative, is between the two ranges. Okay, so potassium nitrate, lithium sulfate, and sodium perchloride, there are some examples of neutral salts. Acid salts. Acid salts, they are formed by the reaction of strong acids with weak acids. Okay, so they have acidic properties. Remember that we are using strong acid and weak acid. Some salts contain the H plus in their structure are also called acidic salt, because when they ionize in water, the H plus ion is formed. As example, we have iron chloride, copper sulfate, and ammonium nitrate. Basic salts. Basic salts are produced from the reaction of weak acids with strong bases. They have basic properties. For example, we have sodium cyanide, sodium fluoride, sodium carbonate. Salts that produce the OH minus ion in water are called basic salts. That is an example for salts. the systematic name and the common name. This systematic name comes from the IUPAC system, and we have the common names. Okay, so NaCl is sodium chloride, and is commonly named as table salt, the salt that we use to prepare our food. We have CaCO3, that is calcium carbonate, and the common name is limestone. We have Na2CO3, that is sodium carbonate, and the common name is washing soda. We have KNO3, that is potassium nitrate, and the common name is saltpeter. We have CaSO4, 2H2O, that is calcium sulfate dihydrate, and the common name is gypsum. Chemical properties of salts. Salts are selective in their reactions. What does it mean? It means that they only react if the conditions are favorable. For example, they may react with metals, but only if the free metal is more active than the metal of the salt. Okay, so silver is less active than copper. That is why we have the reaction. The reason that we have the reaction between copper and silver nitrate. But then the opposite way, the reaction between silver and copper nitrate is not possible because silver is less reactive than copper. Okay, so that one is the free atom, and that is the metal of the salt. That is the free metal, not free atom, the free metal, and that is the metal of the salt. A water-soluble salt can react with an alkali or another water-soluble solution. Alkali are soluble solutions of metals group 1. Therefore, the water-soluble salts can react with alkali or other water-soluble, but then one of the products must to be an insoluble in water, or has to be insoluble in water. For example, barium oxide reacting with sodium sulfate will yield, normally we exchange, okay, that will be barium and SO4. Okay, the oxidation state of SO4 is 2, the oxidation state of barium is 2, they cancel. Okay, so the reaction will occur because the product is insoluble in water, that is barium sulfate. But the same will not happen when sodium chloride reacts with potassium nitrate. Why? Because one of the products, in that case either sodium nitrate or potassium chloride, is the two products are soluble in water. Okay, so this is the formula for sodium nitrate, and we have the potassium chloride. Okay, so potassium chloride and sodium nitrate are both soluble in water, therefore this reaction will not occur. Salts, they may react with acid, but if the following conditions are present. Condition 1, the formation of a precipitate. If a silver nitrate reacts with hydrochloric acid, a precipitate has to be formed, and the precipitate is this one, silver chloride. Okay, so condition fulfilled, reaction occurs. The formation of a weak acid. Okay, we have a strong acid reacting with one salt. I'm sorry for that. At the end, we have a phosphorus acid, that is a weak acid. So a weak acid is formed with during the reaction of a salt and a strong acid condition fulfilled. And then we have the formation of volatile acid from non-volatile acid. The acid that is formed is nitric acid. Nitric acid is volatile. So we have the formation of volatile oxide from non-volatile oxide. Okay? Yeah. Volatile means that when it is in room temperature, it evaporates. Okay, when it is open, if we have nitric acid in a container and we leave it open, it will evaporate. Okay, so that is the definition or the meaning for volatile. Remember that hydrochloric, nitric acid, sulfuric acid, hydrobromic acid, iodic acid, and hydrochloric acid are strong acids, and then hydrochloric acid and nitric acid are volatile acids. That is it for the lesson of salts. You need to do the homework. I'm going to upload using Fedena, so you can go and check. Complete the following chemical equations. We have NH3 reacting with hydrochloric acid. Please tell me the state, the name of the constituent, the product, balance your equation. Okay? And then we have ethanoic acid reacting with sodium hydroxide. Question 2 is to determine whether the aqueous solution of the following salts is acid, basic, or neutral. That is easy. You just need to tell me, is KBr a solid, not solid, a basic salt, or a neutral salt, or an acidic salt? Okay. Good luck. Thank you for participating in that class. That was a very short lesson. Please go through the notes that are in your book. That is just a summary of salt, and please do the exercises that are in the exercises from page 51 to 55. Please go through that exercise. You need to solve them, and if you have any question, please give me the feedback. For example, exercise 16, it says which options gives the correct classification of the salts. You have potassium chloride, potassium hydrosulfate, and BaOHCl. Okay, so you need to tell us if the first one is neutral or it is